I want to give you a few quick things about linear functions. So if you need a review of graphing linear equations or writing linear equations, I actually have many other videos that are related to those. Please let me know if you need more review on those. But I'm going to give you this video with the assumption that you know how to write an equation of a line with 2 points and that you are able to graph lines. So we're just going to do a few quick things. The first thing I want to talk about is, first of all, a linear function is a function whose graph is a line. Hopefully you already know that, but just in case, we'll mention that. So there are a few things that are more related to precalculus and calculus with lines. And the first thing is the average rate of change of a linear function. So you might remember we previously had average rate of change. There was a formula for it. It was like f of a minus f of b over a minus b. Basically, what this formula is the slope of the line. And actually, if you have a linear function, your average rate of change is going to be equal to the slope of the line. And it's not just an average rate of change, it's actually a constant rate of change that you'll have no matter what your x values are. So the second thing is increasing, decreasing, and constant. So a linear function will be increasing everywhere if its slope is positive. It will be decreasing everywhere if its slope is negative, and it will be constant everywhere if its slope is 0. Those are our horizontal lines. So we're going to do an example, and you might notice this example looks really familiar. We've done some problems like this when we were talking about functions. So you're welcome to pause the video and then just fast forward to my answers. So for part A, we want to find all x such that f of x equals 0. So that means we're going to set f of x equals 0. When we do that, if we solve that, we get f of x is equal to 1/2. For B, we're going to find all x such that f of x is greater than 0. So we do 4x minus 1 is greater than 0. We're going to solve this inequality, and we just end up getting x is greater than 1/4. You don't need to do any interval notation if you don't want to, but if you prefer that, it would look like that, by the way. For C, we're finding all x such that f of x equals g of x. Basically, you're just setting these two equations equal to each other. And when you solve those out, you get 6x equals 6, which gives you x equals 1. That one's really nice. For letter D, we are doing almost the same thing. We're finding all x such that f of x is less than or equal to g of x. We're just going to solve this inequality. And the only difference between this one and the previous one is that you get x is less than or equal to 1. Final thing I asked you to do was find the graphs of those two. So let's go ahead and do that. So my first one, I have f of x equals 4x minus 1. We know that the y-intercept is negative 1. We know the slope is 4. We're going to go up 4, right 1. I then am going to draw a line between those 2 points that I just found. You're welcome to plot more points if you want, but you don't have to. For g of x, that one has a y-intercept of 5, so I'm going to draw that. It has a slope of negative 2. I go down 2 and right 1. You'll notice I actually intersect at one of the points that I just drew on the previous one. I can draw more points if I want to. I don't have to because all I need is 2 points to graph a line. So if I draw that, it just looks like this. Not quite the perfect back graph, but it's pretty close. I do want to point out right here, this point, intersection point, is the solution of the graph. It's at 1, 3. So the one thing I want you to notice, I'll go over that in a lighter color so you can see it a little better, is that the value that we got for part C, x equals 1, is actually the same as the x coordinate that we just found there with our intersection point.